Hey, now that we have the powerful wallet objects with balances, public keys, and the ability to assign data, let's create the next key component of the cryptocurrency system, transactions. These transaction objects will capture an exchange of currency between two wallet owners. They'll consist of a recipient and an amount to send. They'll also be officially signed by the sender's wallet. As usual, since we're developing core logic, let's create these transaction objects with test-driven development. So we'll start with a new transaction.test.js file within the wallet directory. So that is transaction.test.js. And to begin, let's require the transaction class, even though that doesn't exist yet. We're being psychic because we'll create this actual transaction file in the future. All right, and now we can describe an overall block of tests. Let's describe the transaction class, and then we have the callback to the describe function. Cool. And to begin, we're going to make a transaction object that will be available for any following test. Let's make this transaction object. And then we're going to add some other variables for the other pieces of a transaction. That way we can build tests off of those as well. First off, only wallets should be able to create these transaction objects. Therefore, a key piece of this is to make a sender wallet that is capable of officially creating transactions. Nice. Now, when conducting a transaction, we're going to be sending currency to a recipient. So let's make a recipient value. And then finally, that recipient gets a certain amount in the transaction too. So make sure you have an amount variable as well. Nice. Now let's assign each of these values in a before each block. First up, we want to assign the sender wallet, and this is going to be an instance of the wallet class. In addition, let's make sure we have the wallet class above, and the wallet is the default file of this wallet directory, so we can require that from the local index file. Cool. And I'm actually missing a pair of parentheses in this before each function. All right, nice. Now we can designate a fake recipient. So the recipient is the public key of the actual wallet that we're sending to. But in this case, we can use any old string. So how about recipient public key? This clearly is not the public key of an actual wallet, but we're using this for debugging sake. And then an amount can be anything as well, as long as it's within the range of the wallet's balance, which by default is 1,000. So let's set the amount to 50, which is a nice, reasonable value. Cool. Finally, we can create the transaction instance. When we create this transaction instance, we're going to pass in an object to the transaction constructor. And this will consist of the sender wallet, the recipient, and the amount. So all the fields that we currently have within this before each block, that'll be part of the object that goes into the transaction constructor. Cool. Now we can write tests for the transaction object since it's available. So as our first test, let's make sure that this transaction has an ID. When we create these transactions, we're going to want to give them unique IDs so that way they can be identified within the blockchain. So our first test says it has an ID. Notice that ID is a keyword, which is why the backticks are being used. And in order to check that the transaction has an ID, well, it's going to have an ID property. So we can use the convenient just to have property method and then look at the ID field. Nice. So now we got to consider how the transaction is going to track how much currency to send to the recipient. One option is to set an amount and recipient property for the transaction instance. So for example, there could be transaction.recipient, and then transaction.amount would relate to how much we're sending to that recipient itself. However, this limits the transaction object to one recipient. Later on, we're going to want to evolve the transaction to be updatable to designate more than one recipient. So to account for this, we're going to introduce a structure for the transaction called the OutputMap. And this is going to have a key for each recipient in the transaction whose value is going to be the amount that the recipient is actually getting. So let's describe this property overall. and we're going to have a describe of the output map, and we're going to have a group of tests for this output map as well. And as the primary test, we're going to do a similar one to our existing ID test. Let's check that it has the property to begin with. We'll have an it test that says it has an output map. And then we can do something similar. We'll expect the transaction to have a property named output map. All right, very nice. So that takes care of making sure the output map exists. However, let's do something more specific with our tests. Let's add a second one that says it outputs the amount to the recipient. So that way we know for sure that the output map contains a recipient key with the value of this amount. So if we access the output map using the recipient as the key, we should expect this to equal the amount. All right, very nice. Now there's one other key piece of the transaction output map. It's actually going to have a field for the wallet's own public key. The value for this is going to be however much amount is remaining in the wallet's balance after sending the amount to the recipient. The reason that we want an output for the sender wallet as well is that we want the transaction to record the remaining balance for the wallet once a transaction is complete. Let's enforce this with the test that says it outputs the remaining balance for the sender wallet. For the sender wallet, and then this is keyword, so we'll use the backticks. And in this case, if we access the transaction output map using the sender wallet.public key as the key in the output map, this should be equal to whatever was the balance of the wallet minus this amount. So this will be equal to sender wallet.balance minus the amount. All right, cool. That completes the initial test setup for the transaction outputs. So once you have everything for the entire describe output map, as well as the ID and all of this setup, head to the command line and fire the npm run test command to get the test suite going. So fire npm run test if you don't already have it going. Cool. And the first error that we're getting is that transaction does not exist. So let's fix that in the next video. If you're hoping to pass the test individually, I suggest researching the UUID module, which will give you an ability to generate a unique ID value for the transaction. The other tests can be passed by creating logic for the output map. With that said, see you in the next one where we get these tests to green.